This is Mr. Hanna and welcome to What the Format. Today we're going to go over a system of inequalities problem. Now, if you look on one of my previous videos, you'll see that there was an inequality, graphing an inequality, a linear inequality that was one inequality. Now we're going to do two. Notice that they're both linear, okay? System of inequalities can be other equations as well. So both in standard form. My first step I like to do is I take both equations and I change them from standard form into slope-intercept form. Do that by subtracting the x term over. Okay, these are not like terms, so I don't combine them. Negative 2x plus 9, then I divide by the number in front of the y. That's a negative 3. Now recall, when you divide by a negative, the inequality has to switch. So what I like to do typically is circle that. That helps me see, then that flips like that. Over here, we have the same steps. Instead of 2x, we had 3x though, so minus 3x. Again, these can't combine, so you got minus 3x plus 30. We bring down the 5y, divide by the 5. Notice I'm dividing each term by these numbers. Negative 3/5, 30 over 5 is 6. Now, it's okay that these are not divisible. These are now your slopes. Okay, there's your y-intercept. When you graph, you always find your y-intercept. For this first line, I'm going to hit minus 3 here, go up 2 over 3, or down 2 over 3. Now notice that's up to the right. That's my positive slope, so I did it right. Notice also it's dashed. Okay, why? There's no equals underneath it. So this right here is a dashed line. Why? No equals. Over here is an equals line, so that makes it solid. Something you need to remember. If you do not get your line right, if you put a solid line with dashed or dashed on a solid, you will get the problem wrong. Okay, now notice it's greater than. So where's greater than? Right here. See now how I hatched up there like this? That's a little hard to see that because of the double shading that's going to occur. But you can see that I shaded above this line, nothing below it. Below is out of bounds. How do I know that? Well, go back to your shading rules. Okay, positive slope, negative slope. Anything below like that is less than. Anything above is greater than, equal to same area. Okay, the only difference is, of course, then since these are less than, probably should have what? Dash those lines, but I'm just trying to show the shading, so I'm more concerned right there where the shading is. Notice that below, so less than would have been below here. I'm greater than because that switched, I'm above. Now this line goes to plus 6. Now these are always your y-intercepts. I see a lot of students sometimes they go to the x-axis. They don't really understand what this means. They start on the wrong numbers. This always starts on the y-axis. Notice negative 3 on the y-axis, plus 6. 1, 2, 3, 4, 5, 6 on the y-axis. Now, from there, that's where you do your slope. So notice up from here, I went up 2 over 3. Why? Because rise of 2, run of 3. So this is rise of 3, run of 5. So I'm going to go up 3, but now it's negative, so I go left 5. Or I go down 1, 2, 3, and right 5. Okay, it's a solid line, so I did a solid line. Notice that it has the negative slope. I'll quickly check that. If you get the wrong slope, that's going to be a problem. Okay. These have nothing to do with the x-axis. Yes, they're in front of the x, but we're not finding any of these points or anything like that on the x-axis. We're doing the slope from our y-intercept. Now this one, notice, is less than. So less than, I shaded here. You can see the shading kind of come all the way down to here. And then what I'm interested in is where the shading overlaps. Well, this shading is all by itself. So is that. Where's the overlap? In here. You shade this area in here like that. That shaded area is now the solution to your inequality. And if you were on a standardized test, you'd have 4 or 5 graphs to choose from, and you would have to choose that graph. You wouldn't necessarily have to do it yourself. Now, if you're in a free response situation, you would have to draw the graph yourself. Most of the time anymore, I see though, these are done with multiple choice, so you just have to identify the graph. So what you have to really watch for is where the shading occurs. You have to watch whether the lines are solid or dashed. I've seen a lot of these where they'll shade the right area, but they'll have 2 dashed lines or 2 solid lines. And so that'll confuse the student because they forget to check that they're only looking at the shading. So this is an example of a lot of things that you've done and learned in the past coming together in one problem, okay? And you want to see the steps. Now, if I were writing down the steps, okay, my steps, I have 3 of them, okay? I like to actually think of it maybe as 2 first, okay? Now, why did I put 3? Well, because after you get these in slope-intercept form, you have to graph them, and then you have to shade them, so technically that's 4, maybe even 5 steps. But I like to think of it in terms of breaking the problem down 2 steps. What is my 2 steps? Well, I have to solve for y, right? Solve for y. How do I do that? I subtract the x term over, right? From both sides, right? Let me clean those up. Sometimes I get writing too fast. That's one of my problems, is I tend to go too fast. I have to slow myself down, okay? There's not a race here. And then the last thing you do is you have to what? Divide by number in front of the y. And then we have to do what? Graph both lines. So these would be my 2 steps right here. And the reason why that's important is because if you don't get them into a graphable form, anything after that is a problem. And I see a lot of students, they can't do these steps. So then even if you knew how to graph them, it doesn't matter if you can't get to that point. And that's what happens with a lot of Algebra 1 problems and algebra problems. Even after Algebra 1, get to Algebra 2 into calculus, the students understand what to do. They can do most of the problem, but there's always 1 or 2 things that maybe they missed or they've always struggled with. You have to be able to do all these steps. Doesn't take much to get wrong, right? Now, me writing this down is an example of what I might do if I were in a class, or you're watching one of my videos and I say something that you really like, go write it down and then put it into your own words. Maybe you like to think of it a little differently than me. Notice I didn't write anything about switching the inequality. You could put that right there too. Oh, if that's a negative number, flip the inequality. And then, you know, what would you put here? Shade. Watch your solid or dashed. Okay. Anything that you need to put down to help you see your process, and then you memorize that process because it's going to be the same every time. Okay. Again, I see a lot of students, they just don't memorize and they forget. That's a problem. Anyway, this is an example of how to graph the system of inequalities, a partial example of how to write the steps out. Now, in my case, I already I remember about the switching the inequalities, and once I say graphing both lines, I know about the shading. So I might not write anything else because I don't need it. Well, maybe, like I said, you need to put more notes on this. Whose choice is that? Well, that's yours. Okay, so I didn't cover the shading. I didn't cover the switching the inequality, and in my notes here, I didn't cover solid or dashed lines. You notice I did do that when I actually solved the problem. Okay, so I knew what to do, and that's where, like I said, these notes are more for you and what helped you. This is just an example of what you might write to help you out. Not meant to be a complete set of steps. This is more just kind of, oh, I have my first 2 steps, solve for y, bam. Oh, then I'm gonna graph both lines. And maybe this is the one I think of as in 2 steps because that's so important. Then I graph the lines, shade. Okay, now I've repeated myself a lot. Why? Repetition is the key to learning. If you can repeat the steps over and over in your head and you've got each one and you know what they are, you're good to go. If not, you need to go back and practice some more. Anyway, this has been Mr. Hanna with What the Format. Thank you for watching and happy mathing.